Today, we are going to dive into genetic algorithms and grammatical evolution for trading. So let's just go ahead and jump right in and see where we left off. You can see here that we read two papers yesterday about grammatical evolution and another one about grammatical evolution as well. One was using LSTM models. One was using some other stuff to create these genetic algorithms, and grammatical evolution is like a subset of that kind of. But let's go ahead and keep going through this. And the first thing I want to do here is I want to take what we've done and just get right into it. So you can see here I have this code. Please explain this code step by step so we can get all up to date. Please explain this code step by step. And then what I want to do here is I want to implement some of my own kind of ideas, I guess. Let's go ahead and get a little refresh here. I want to implement some of my own strategies to this because I feel like this is part one here. And we've got the code that is a genetic algorithm. We also built a GA a little bit a while ago. This is actually grammatical evolution. But this is the second version of this because there's unlimited ideas here, right? So there's unlimited things we can build with genetic algorithms. If you don't know what genetic algorithms are, you're about to get a definition. So hang on there. I'm kind of shocked that some people don't use them, but I think it's kind of out there. So let's go ahead and say, please explain this code step by step. Okay, let's start with that. Okay, so this script is designed to optimize a trading strategy using a genetic algorithm GA with the deep library and the backtrader framework for backtesting. Below, I walk you through the code step by step. So this is just a bunch of imports. These imports are libraries like pandas, numpy, etc. This loads in the data. This part reads the trading data from a CSV file and then sets the date time column to the index. This goes ahead and makes folds, so sections of the data, so we don't look at the whole data the whole time. This is the actual strategy part, and it's interesting to me that we write it in a string. It's a text version of the strategy. And then this part defines the strategy in Backtrader. The strategy involves various indicators and conditions for buying and selling. Then down here, this is the function converts a genotype, which is a list of integers, into a phenotype. Actual parameter values by mapping the integer values to corresponding parameter lists. You can see this is the KPI part, what we're looking at the KPIs. So this function evaluates the trading strategy by converting the genotype to phenotype, instantiating the Cerebro engine, adding data and strategy to the engine, adding analyzers for performance metrics like Sharpe ratio and drawdown ROI, running the backtest and returning the performance metrics. Here, this part sets up the genetic algorithm using the deep library, defines the fitness function, maximize Sharpe ratio, creates the individuals, the genotypes with random integer attributes, defines the population as a list of individuals, registers genetic operators, crossover mutation selection, and then defines the evaluation function to get the KPIs. Continue, dog. Don't ever stop on me, please. Never stop. Keep going. Just keep going. Just keep going. Don't quit on me, dude. Don't quit on me now. So you can see this line runs the genetic algorithm using the EAMU plus lambda algorithm from deep. Population, the initial population. So we pass in the initial population, the toolbox. Down here, this part selects the best individual from the final population and stores it in the best solutions list. This loop evaluates the best solution across different folds, the train, the validation, and the test. This part converts the results dictionary to a pandas data frame and prints it. Finally, this part creates a data frame to store and print the best solutions parameters. This code optimizes a trading strategy using a genetic algorithm. It involves the following steps: data prep, strategy definition, genetic algorithm setup, evaluation function, running the GA, and results. Can you explain what a GA is and how it is different than grammatical evolution? Because it's different. Definitely different. I'll tell you that much, but I'm still learning as well. So I'm just showing you as I go. As always, genetic algorithms are search heuristics that mimic the process of natural selection. They are used to generate high quality solutions for optimization and search problems by relying on bio-inspired operators such as mutation, crossover, and selection. GAs are particularly useful for solving complex problems where traditional optimization methods are ineffective. So the population is a set of solutions to the problem. The individual chromosomes, each individual represents a potential solution encoded as a string of genes. Genotype, the encoded form of a solution. Phenotype, the actual solution represented by the genotype. Fitness function, a function that evaluates how good a solution is, typically returning a numerical value indicating the solution's quality. The selection, the process of choosing individuals from the population to create offspring based on their fitness. Crossover or recombination, combining parts of two parents to create offspring mimicking sexual reproduction. Mutation, introducing random changes to an individual's genotype to maintain diversity in the population. Initialization, generate an initial population of random individuals. Evaluation, calculate the fitness of each individual in the population. Selection, select individuals based on their fitness to create a mating pool. Crossover, create new individuals by combining parts of selected parents. Mutation, apply random changes to the offspring. Replacement, form a new population by replacing some or all of the old population with the new individuals. Termination, repeat the evaluation, selection, crossover, mutation, replacement cycle until a stopping criterion is met. So in context of optimizing a trading strategy, GAs can be used to find the best set of parameters, like a stop loss, take profit levels, that maximize performance metrics like Sharpe ratio. Grammatical evolution. Grammatical evolution is an evolution algorithm that involves programs or expressions in any language defined by the Backus-Naur form, BNF grammar. It extends genetic programming, GP, by using a genotype to phenotype mapping process, allowing the algorithm to generate syntactical correct programs. So key concepts are the genotype. Again, this is grammatical evolution. Now I switched up on you. A string of integers that represent production rules in a grammar. Phenotype, the actual program or expression generated by the genotype using the grammar. Grammar, a set of production rules, BNF grammar, that defines the syntactical structure of a valid programs or expressions. The fitness function, a function that evaluates how well a generated program or expression solves the problem. So initialization, generate an initial population of random genotypes. Genotype to phenotype mapping, use the grammar to map genotypes to phenotypes, generating syntactical correct programs. Evaluation, calculate the fitness of each phenotype. Selection, select individuals based on their fitness to create a mating pool. Jeez. Crossover, combine parts of selected genotypes to create offspring. Mutation, apply random changes to the genotypes. Replacement, form a new population by replacing some or all of the old population with the new individuals. Termination, repeat the evaluation, selection, crossover, mutation, replacement cycle until a stopping criterion is met. So the example of generating trading rules in context of generating trading rules, GE, genetic algorithms, can be used to evolve expressions or programs that define trading rules using a predefined grammar. The difference between GA and GE representation. GA individuals are typically represented as fixed length strings of binary values, integers, or real numbers. GE's individuals are represented as variable length strings of integers that map to production rules in a grammar. So the solution space, GA, searches a space of encoded solutions directly. The GE searches a space of syntactical valid programs or expressions defined by a grammar. Flexibility. Generally, GAs are flexibly more straightforward but limited to the representation used. GEs more flexible due to using grammars, allowing for the evolution of complex structures like programs. Mapping. GAs are direct mapping from genotype to phenotype. GEs indirect mapping from genotype to phenotype using a grammar. Applications. GA often used for parameter optimization and combinatorial problems. GEs are used for evolving programs, generating expressions, and other tasks where a structured solution is required. Both genetic algorithms and grammatical evolution are powerful evolutionary algorithms used for optimization and search problems. GAs are well suited for direct parameter optimization, while GE is more suitable for tasks requiring generation of structured solutions such as programs or expressions depending on the problem at hand. One may choose GAs for simplicity and direct optimization, or GEs for its flexibility and ability to generate complex solutions. What are the pros and cons of each for trading and building trading algorithms and profitable trading systems? How would you approach this? You are the quant Jim Simons. Why not? You are him. What would he say? If you're on Jim Simons, Google it. Genetic algorithms, pros and cons. They're easy to understand. Genetic algorithms, GAs. Easy to implement and understand, well documented and widely used in various optimization problems. Efficient parameter optimization, effective in finding optimal or near optimal parameter sets for trading strategies. Can handle complex multi-dimensional optimization problems. Flexibility can be applied to various types of data and problems in trading, such as optimizing entry and exits, risk management parameters, and portfolio allocation. Robustness, tolerant to noisy data, which is common in financial markets. Parallelizable, easily parallelizable, which can significantly speed up the optimization process using modern multi-core processors or distributed computing systems. Cons. Premature convergence. Risk of converging to local optima rather than finding the global optimum. Requires careful tuning of algorithm parameters such as crossover mutation and rates to avoid the issue. Computationally intensive, can be computationally expensive. especially for large populations and many generations. High computational cost if the evolution of the fitness function is time consuming. Limited to parameter optimization, focus on optimizing numerical patterns, which may limit the scope of solutions compared to the more extensive methods like GE, grammatical evolution. Grammatical evolution. Flexibility and expressiveness, capable of evolving complex structured solutions such as trading rules, algorithms, and entire programs. Can generate new trading strategies from scratch, not just optimize existing ones. Grammar base ensures that all generated solutions are syntactically correct, reducing the risk of invalid strategies, allows for the incorporation of domain knowledge through the grammar definition. Exploration of larger search spaces can explore a wider variety of solutions, including unconventional or novel trading strategies that might not be found by traditional optimization methods. Adaptability can be adapted to various types of problems beyond parameter optimization, such as generating predictive models, trading rules, and portfolio management. Cons. More complex to implement and understand GAs. Requires a well-defined grammar, which can be challenging to create. Computationally expensive. Similar to GAs, GEs can be computationally expensive due to the evaluation of complex phenotypes. The genotype to phenotype mapping process adds an extra layer of complexity and computational cost. Parameter tuning requires careful tuning of evolutionary parameters, mutation and crossover rates, and grammar to balance exploration and exploitation. As Jim Simons, a quant with a focus on rigorous scientific and mathematical methods, here's how I would approach trading algorithms and profitable trading systems using GAs and GEs. Define objective and constraints. Maximize risk-adjusted returns, Sharpe ratio, while minimizing drawdowns. Constraints. Limit maximum drawdown. Ensure liquidity. Adhere to risk management principles. Data preparation. Gather and pre-process high-quality financial data, including historical price data, volume, economic indicators, and the other relevant data sets. Clean and normalize the data. Handling missing values and create features that capture more important market dynamics. Strategy formulation. Using genetic algorithms, GAs, initialize population, create an initial population of random trading strategies represented by their parameters, like moving averages, stop loss, take profits. Evaluate fitness. Use a robust backtesting framework to evaluate the fitness of each individual in the population based on performance metrics like Sharpe ratio, drawdown, and ROI. Get this boy out of here. Shorting Filecoin, get him out of here. 256,000 off his chest. Good night. Bye-bye. Good night. Bye-bye. Selection. Select the top performing strategies to form a mating pool. Crossover and mutation. Apply crossover and mutation operations to create new offspring. Ensuring diversity and exploration of the search space. Replacement. Replace the worst performing individuals with the new offspring. Iteration. Repeat the evaluation, selection, crossover, mutation, replacement cycle for a predefined number of generations or until convergence. So using grammatical evolution, define grammar. Develop a grammar that defines the syntactical structure of valid trading strategies, including technical indicators, mathematical operations, and logical conditions. Initialize population. Generate an initial population of random genotypes that map to valid trading strategies using the defined grammar. Genotype to phenotype mapping. Translate genotypes into phenotypes, trading strategies using the grammar. Evaluate fitness. Backtest using generated strategies to evaluate its performance based on identified metrics, defined metrics. Selection, crossover, and mutation. Apply selection, crossover, and mutation to evolve the population similar to GAs. but the added complexity of ensuring syntactical correctness. Continue the evolution process until satisfactory solutions are found. Validation and robustness testing. Perform out-of-sample testing and walk-forward analysis to validate the robustness and generalizability of the evolved trading strategies. Conduct stress testing under the various market conditions to ensure the strategies can withstand different market regimes. Implementation and monitoring. Implement the optimized trading strategies in a real-time trading environment. Continuously monitor and evaluate the performance of the strategies, making adjustments as necessary to adapt to changing market conditions. Conclusion: both GAs and GEs are often powerful methods for developing and optimizing trading strategies. The choice between them depends on the specific requirements and goals of the trading system. GAs, genetic algorithms, are simpler and effective for parameter optimization of strategies. GEs provide greater flexibility and the ability to generate entirely new trading strategies from scratch. I like that. I'm excited about that. Oh, I'm excited about both, but given the need for both optimization and innovation in new trading strategy, a hybrid approach, leveraging both GAs. Nice. I like the hybrid approach because my goal is to generate brand new strategies that a human can't comprehend or find easily, and then also optimize those strategies. Jim Simons, who you are, what would you recommend I do next? Jim Simons, who you are, what would you recommend? Yo, 777, everybody. Good morning, Tone. Good morning, Nuno. Good afternoon, Jane. Good evening, Lone Star. Good afternoon, Sakar. What up, 777? Danny, what up, 777? What's the best place to learn Python? YouTube. Sakar, don't even when you don't like me. I love you, bro. 777, Davey. Good to see you. Leighton says, is this the last cycle for human trader efficiency with AI making us fairly obsolete? There's always going to be human traders for sure. Are they going to be good? They aren't now. So there's always going to be gamblers. There's always going to be, us gamblers going to the casino gambling. So I think traders will always be here, but they're going to continue to get wrecked. So I'm going to continue to algo trade. Yo, what up, Derek? Good afternoon. Good morning. Sweet dreams. As Jim Simons, a quant with a track record of developing groundbreaking trading strategies, here's what I would recommend for your goal of generating brand new strategies and optimizing them with using a hybrid approach of genetic algorithms and grammatical evolution. Define a comprehensive research plan. Develop a framework that combines the strength of GE for generating novel trading strategies and the efficiency of GAs for optimizing these strategies. So build a framework that uses grammatical evolution to generate strategies and then use genetic algorithms to optimize those strategies. Include various market conditions, asset classes, and timeframes to ensure robustness. Develop a robust framework. Define the grammar. Create a detailed grammar that includes a wide range of technical indicators, mathematical functions, and logical operators. Nice. This looks Gucci. Expandable grammar. Ensure that grammar can be easily expanded to include new indicators or functions. What is this? This looks a lot like a grammar if you ask me. Genetic algorithm setup, popularization, initialization. Start with a large initial population of random strategies. Fitness evaluation. So I want to write this down because I think this is really good. Jim, rest in peace, homie. Rest in peace, bro. Thank you for your guidance. Plan. Dude, that doesn't look good. Objective. I'm just going to put objective. That's the only one I want. Perfect, perfect, perfect. Life is perfect. Good to see everybody here. 777. Let's go ahead and keep it moving and develop a robust framework. Okay, genetic algorithm setup, popularization, initialization. Start with a large population, then fitness function, then selection, crossover. Then hybrid framework, GE for strategy generation, uses GE for the strategy, and GA for optimization. I love that. Implementation steps, data collection and pre-processing, gathering historical market data across multiple asset classes and timeframes, clean and pre-process the data to ensure consistency and accuracy. Define the evaluation metrics, establish a set of evaluation metrics that will be used to assess performance of trading strategies. Metrics include Sharpe ratio, maximum drawdown, return on investment, and number of trades. Develop the GE and component. So grammar definition and parsing. Define a flexible and comprehensive grammar for generating trading strategies. Implement a parser that can translate genotypes into executable trading strategies. GE implementation. Develop the GE engine to evolve trading strategies by generating and selecting the most promising candidates. Parameter optimization. Implement a GA to optimize the parameters of the trading strategy generated by the GE components. Fitness function. Design a fitness function that accurately reflects the desired performance characteristics of the trading strategies. Hybrid framework. Integrate the GE and GA components into a cohesive framework. Ensure seamless interaction between the two components. Backtesting and validation. Perform extensive backtesting to validate the performance of the strategies generated and optimized by the framework. Conduct out-of-sample testing. Iterative refinement and improvement. Continuously refine the grammar, genetic operators, and fitness functions based on the results of your testing. Explore the incorporation of additional data sources, such as sentiment analysis, newsfeed. Automation and monitoring. Develop automated tools for continuous monitoring and evaluation of the trading strategies in real time. Implement alert systems to notify you of significant changes in strategy performance or market conditions. So since the GE will take a long time to search for the best. No, I'm not going to say that. I'm just curious. Things. Would it be beneficial to use a coding language like Rust to speed up the search? I've already implemented NumPy to speed it up, but I'm just thinking of other ways to speed up the GE. What do you think, Jim? Jim, what do you think? Using a more performant language like Rust indeed helps speed up the computation intensive parts of the grammatical evolution and genetic algorithms. Here are the steps and considerations for optimizing performance of your strategy generation and evaluation processes. So profile your code, identify the bottlenecks in your current implementation. This will allow you to focus on your optimization efforts on the parts of the code that will benefit the most from increased performance. Make sure you are leveraging parallel processing to evaluate multiple strategies concurrently. Using multi-processing in Python is a good start, but more efficient parallel processing libraries or frameworks might be needed. Use efficient data structures. Ensure that you are using the most efficient data structures for your problem. In Python, this means leveraging NumPy for numerical computations and using efficient algorithms for data manipulation. Algorithm optimization. Optimize your genetic algorithm operation, selection, crossover mutation. Use high-performance libraries like Numba or Cython to compile Python code to machine learning, significantly speeding up execution times. Rewriting performance critical parts of your code in Rust can provide significant speedups. Rust safety guarantees and performance characters make suitable choice for computational intensive tasks. Set up Rust project. Write code in Rust. So by combining Python for flexibility and ease of use with Rust for performance critical sections, you can create a highly efficient system for evolving and optimizing trading strategies. Here are the specific steps you should follow. Profile and optimize Python code. Identify and optimize bottlenecks using profiling tools like Numba. Implement parallel processing. Use Python's multiprocessor capabilities to evaluate multiple strategies concurrently. Integrate Rust for speed. Rewrite performance critical parts of your code in Rust using Py-O3 to achieve significant speed improvements. This hybrid approach leverages the strength of both languages, providing the flexibility needed for complex algorithm development while ensuring high performance. Okay, so I'm not going to do Rust right away. No way. Maybe use Rust later. Use Rust later in order to speed this up. Let's go ahead and look through our notes because we've been working on this for a while. June 10th, building out math only on grammatical evolution, working through all of the edge cases with Luxy. I've already saved to the prompt, so it has all of my code. Perfect. So to finish the math on GE, do a GE for every single indicator on Pandas TA and TA lib. Ooh, that's gonna be so sick. Switch to backtesting.py once I'm comfy with it. So we just wrote that one down. Ideas, a ML combo identifying pivots using weighted factors like EMA, SMA, Keltner bands with ATR multiples, fibs by significant levels, max, and RSI. Instead of blending the plus minus multiplication, maybe separate them individually, and after finding a working model, merging them together. You should try the Murray math line indicator with an entry strategy at the MML extreme overshoot. Good entry for strategy of MACD divergence breakouts. All right, well, this is kind of off topic, but I'll put it on my note sheet. I'll be putting your guys' ideas in here as well. So I'll be listening. I'll be reading everything, dude. So anything you put out, I read it. So make sure it's good. Make sure it's good, or else I'm connecting your name to trash. Make sure whatever you post anywhere on the internet to me, make sure it's good, or I know you're trash. Your idea is trash. Your name, it's connected forever. It's connected forever, dude. Like some dude hit me in the chat just today, said, even though when you hate me, it's like, yeah, it's because you said some whack stuff yesterday and I remember you forever. And you're whack forever. Sorry, B. You're whack until you prove yourself otherwise. 777, much love. Go through all the TA library and combine all the indicators. That's going to be dirty. V-plan, so I'm also working through this other set of code. Okay, I'm set. I'm ready. Let me answer any questions here if there are any. Masari CEO steps down. That guy's a fool. I called him out 3 months ago for his antics and he blocked me, and now he had to step down from his company. It's very easy to see. That's what I woke up to. Masari. It's very easy to see fools on the internet, and yeah, he should have stepped down a long time ago. But 777, Derek, 777, Jane, much love, much love. Let's keep going. Let's keep going. Let's keep going. So what I want to do now is go ahead and take this, and I want to update this. I don't have access to this backtesting.indicators, so I want to remove it first off. So let's go ahead here and say, boom, please update this code above in order to remove the from backtesting.indicators part and then change the backtesting from backtrader to backtesting backtesting.py. And then lastly, change the strategy we are using as the base strategy to the one below. I don't have access. I don't have access to all of the. Okay, let's just say that. Let's go ahead and find this. Danny says I put you in the background so I don't feel alone while coding. That's so dope, bro. Glad to be in the office with you. Let's get it. Let's get it every single day around 8 or 10 or 11 or 12. All day. Doesn't matter when I'm here, I'm here. And I'll keep coming back every single day. Every single day. What is this? Break down all data. That looks return 20%. What's this breakdown? Gap data. 117% return. Breakdown hourly. I don't want anything too good. Return 37%. Break out. This is our best one, but I mean, it's just out of one I picked at least. I just don't really want to do it on gap data, so I'm just going to use this strategy. I don't even know what it is. Here's the strategy. Here is the strategy we want to work from. So, okay, now I get this out of here. Get it out of here. Get them ghosts. And then I go over here, say vid 1 and 2. Vid 1, 2. Day 2. BTY. So this is from extended from vid 1 and 2. But this one is focused on backtesting.py plus a strategy I have access to. I'm sure I can find the other one strategy, no worries, but just like right here, right now, you know? Right here, right now, in front of me. I don't have access to it. I see dead people. Man down. All right, let's go ahead. Trying to see Compton. Let's go ahead and see what this looks like, dude. Random. Come on, blood. Let's get it. Pop out and show. Jane says, Danny, listen daily whilst I'm coding my AI stuff and learning while I'm coding. Switch. Derek said, just got a friend request from you and on Discord. Moondev, is it real? No way. It's not real. Report it. Wop, 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 wop. I love you, Derek, but I'm never going to send you a friend request or send you a cold DM. It's always fake. If there's any dots, any underscores, anything like that. Thank you, bro. They not like us. They not like us. They not like us. I think that Oakland show gonna be. Let's stop. Let's go ahead and run it here. Deep. You don't have deep? How you not have deep? I was just running this the other day. T-Flow, Conda. Something. Bitch jump in. What do you mean I don't have it? No module named Deep. I thought it was named differently, but let's go ahead and just throw it in there. Get the pip install from her because I don't want to go to Google. Who uses Google anymore? I don't. Pip install Deep. See, it's already installed, cuz. Send it up the pot. Hey. Say. Oh, that's why. Conda deactivate. They're not like us. They're not like us. What do you mean? Pip install deep. It's already in there, cousin. Don't play me today, dog. Not today. Not today. Not today. A real challenge. All right, let's go ahead here. Hey. Pip install deep. I'll try this. I mean, it says it's going to activate some stuff. You're a Why are you on quant is my question. Mm. Snanga. Run for your life. Conda. Deactivate. Conda activate. T-flow. Pip install. Get out of here, B. Come on, bloody. All right. I guess I don't know how to do this anymore. Because I thought I had the deep library in here and we were running it just the other day. But maybe I'm tripping. Maybe I'm tripping. Let's go ahead here. Vid 1 and 2. V1 and 2. Okay, that looks Gucci to me. Where we at? VGE? Yeah. Let's just go look up pip install because it seems something weird is going on. But typical day, typical day. Damn. Oh my god, I was like, what is that? My computer is loud as shit. But it was the rain noise. Call you. Pip install deep. It's in there, dude. I can promise you that. I showed you it's that. Okay. Not that. No. Okay, Dropbox, dev. Bro. Okay, pip install. Why are you on quant? That's why I don't get. Get out of here. I'm just going to close it. How you like that? There we go. Something's going on now. Perfect, perfect, perfect. Fuck you. All right, let's go ahead and run this. The error you're encountering is due to the multiprocessing library on Mac OS and others. It's important to use if name is main. Oh my god, I have to use name is main. Get him out of here. Take me out in the chopper if I have to use name is main. Gosh darn it. I've got to use name as main, fellas. You know I don't like using name as main. It's intimidating to me, dude. It is what it is. And you know what? Honey, make the word. Went gold, you know? All right, let's use this name as main. We don't know how to use it still, but it's okay. Why is this now gone? BT.analyzers? Come on, blood. Looks like we are missing BT now. The line. These lines all don't work. And why is you using Cerebro? And remember, we are using backtesting.py, cousin. Not Cerebro. Cerebro is backtrader. You know, we're having SCAR go, you know? You know, they fold. Come on, baby. All right, this is a lot of code, but it's all good because that's what we need. Get them out of there. Get them all the way out of there. Oh, snap. You know what I did the other day? Just now? I got rid of my notes up here. No way. We don't do that. We keep the notes up there. We got standard deviation here. We got the fitness. We got everything we need, dude. There's no time to catch up. There's no time to catch up. If you fell behind, there's nothing to do but catch up. Bro, if this doesn't make sense to you, you fell behind. And if you fell behind, there's nothing to do but catch up. Maybe change your mindset and get a new perspective. That's it, bro. Come on. You know. All right, let's run this and see what's Gucci. Touch bro just went go, you know? You know. Oh, man. The problem here is fudge. I need to put something more simple. I need to put something more simple. Because this is going to test it for all of them. All right, let's find a different mediocre backtest. I want to use a mediocre for a reason, cousin. I don't want to use the best. Actually, it doesn't matter. It just doesn't matter to me. It doesn't matter to me. I just want to get the functionality of this done. You know? On you. How about this little mean reversion strategy? I am not smoking. Not yours. All right, how about this one? Yeah, let's do this one. So this is a reversion strategy, a mean reversion strategy. Update the above so it uses the below strategy instead because it only has one data path instead of a full folder. So this will be much better for the initial version. Here is the original GA. Please use backtesting.py like I mentioned before. Please, please, please. Love you. Maybe run multiples. Just an idea. Probably a later thing. What do you mean? What do you mean, dude? What do you mean multiples? ¿Qué es multiples? Múltiples. Guess. I don't know what you're talking about. Multiple data sources? Multiple folders? Multiple moon devs? Multiple, multiple K. Multiple K. Separate backtest into a singular program runs. Separate the backtest into singular program runs. Don't even think about it, bro. Just keep going. Don't even think about it, bro. Just keep going. Did it put the new one in there though? Is the question. NumPy, good, good. Bollinger Band breakout short. What the F, bro? It's not the one, cousin. I probably didn't put it in there. That was my bad. That was my bad. Mala mia. It was totally my bad. I didn't put the strategy in there, dum dum. Come on, Mooney. Get this together. Here is the new strategy to use instead of the one above. Okay. Let's go get it again. I got it right here because we do this every single day, dude. You can't compete. You can't compete. Just get on the team. Come on. You can't compete. Come on, B. You can compete. That's fine. Let's go. Compete. Let's go. Let's go. Step on the gas, B. If you want to know everything I know, it's in the boot camp. Don't even think about it, bro. Just keep going. I don't care if you do this with or without me. I'm coming at your neck either way. So let's go. Let's level up. Let's level up. Let's level up. Every day. Every day. I'm here. I'm here. I hope you wake up and you see me on YouTube every single day. I do this for a reason, dude. I want you to know how hard this is. I want you to know who's on the other side of every single trade that you take. So come on. Let's be on the same team. I'll show you everything I know. I don't know everything in the world by any means. I'm only in year 4. So all I know, bro, is that I'm going to keep going. Don't even think about it, bro. Just keep going. Every day. Make a commitment. Come on, that's it. Make a commitment to every single day you'll be here. You can have me on the other tab, just whatever. It doesn't matter. Let's just get it every day. Let's go ahead and see if it put in that new strategy, or else I'm going to break this computer down. Oh, okay. There we go. It's just a little mean reversion off the SM Izzy. Who am I? Ripley's? Boosted off the caffeine. OMG. Thanks for helping me, Moondad. Tone had a little caffeine. Nice. There we go. Derek says, wait, that wouldn't work. Never mind. I'm apparently not awake yet. Not using my brain. It's all good, dude. Get some of that Phil's coffee in you, bro. Tone says he'll begin to code smaller sneaker projects to get started and work my way up to bigger algos like you. Will teach the power of code along the way. My dude. However you teach it, bro, please let me know because I'll help, get that to more people because there needs to be more people teaching. It's just like people think it's too hard. And yeah, people think it's too hard and we need more regular people just like showing that it is hard, but it's not harder than anything else. And life is supposed to be hard. If you go to bed at night and your day was easy, like, what are you on vacation? Was you on vacation or something? Damn. I don't know how I think I used to play basketball when I never can make the trash can from here. Oh man, had to medicate myself last night. Damn hangover. I'll shut up and watch 777. Much love, bro. You be medicating with alcohol? Honey makes the wood burn slow. Did you know that? Let's go ahead and see if this one is Gucci now. Honey make the wood burn slow, We have an escargot, Those Percocets are going to wear off, Import warnings, cousin. What is you doing? Siri, you always try to come up on my day. Siri, every single day you try to come up here. I ain't talking to you, all right? Damn, dude, Derek has nerve damage, CBD and THC. Prescription dosage. Oh, so you're lit this morning. Damn, I hope it gets better somehow, man. That's sketch. But I'm glad there's something will help a little bit. And I'm glad you're going more of the natural way, you know? So data must be in Panda's data frame. What data are we using, dude? Because you know I'm a data dog. You can see grammatical evolution, Bitcoin 5 minutes, CSV. Is that the one? Let's say copy path. Dude, I love this game. I love this game so, so much. Don't get involved if you're not going to die for it, though. I'm going to tell you that. Don't get involved if you're not going to die for it. Anything you do, dude, just make sure it's the one thing. The most important thing. That's it. I was about to build a website today. I was like, hell no. I am not going down that path again. F websites, F HTML, F all that. F the front end.